Hello everyone, and welcome back to our Network Plus course. Today, we're diving into the fascinating world of routing technologies. Routing is essentially the roadmap that guides data from one point to another across networks. Let's begin with static routing. Imagine you're planning a trip to a friend's house, and you decide on the exact route you'll take beforehand. You know every turn and intersection along the way, and you stick to that plan no matter what. That's similar to how static routing works. In static routing, we manually configure the routes on a router. This means telling the router exactly which path to use to reach a specific network. Dynamic routing. Now, let's talk about dynamic routing. Continuing with our travel analogy, dynamic routing is like using a GPS navigation system that automatically adjusts your route based on current traffic conditions, road closures, or accidents. Dynamic routing protocols enable routers to discover network destinations and determine the best path automatically. This approach is much more scalable and adaptable. Now, let's delve into three important dynamic routing protocols: BGP, IGRP, and OSPF. Border Gateway Protocol. BGP stands for Border Gateway Protocol and is often referred to as the backbone of the Internet. It's what allows different networks, or autonomous systems, to exchange routing information. Think of BGP as the system that maps out the major highways connecting different cities across the country. Enhanced Interior Gateway Routing Protocol. Developed by Cisco, it's a hybrid routing protocol that combines features of both distance vector and link state protocols. Imagine EIGRP as a sophisticated local navigation system within a city, efficiently directing traffic through various routes to avoid congestion. IIGRP is known for its fast convergence, meaning it quickly adapts to changes in the network. It uses metrics based on bandwidth and delay to determine the best path. Since it's proprietary to Cisco, it's primarily used in networks that utilize Cisco equipment. Open Shortest Path First. OSPF stands for Open Shortest Path First and is a widely used link state routing protocol. It's like having a detailed city map that always knows the shortest path to your destination. OSPF builds a complete topology of the network and uses Dijkstra's algorithm to calculate the shortest path. One of the advantages of OSPF is that it's an open standard, so it can be used in multi-vendor environments. Now, how do routers decide which path to take when there are multiple options? They use several criteria: administrative distance and prefix length. Administrative distance. Administrative distance is a value that indicates the trustworthiness of a route. If a router learns about the same destination from different routing protocols, it uses the administrative distance to decide which route to prefer. Lower values are considered more trustworthy. For example, directly connected routes have an administrative distance of 0, making them the most preferred. Static routes have a distance of 1, while dynamic protocols like EIGRP and OSPF have higher values. Prefix length. Prefix length refers to the subnet mask of the IP address. When choosing between routes to the same destination, the router prefers the route with the longest prefix length, meaning the most specific match. In conclusion, understanding routing technologies is essential for designing efficient and resilient networks. Thank you for joining us today, and see you next time.